Welcome back. So I have another example where we're going to use some models based on some observations of real-world data. And I'm starting with this graph here. These are the average cost of room and board at four-year public and private U.S. colleges for various years. We have data from 2011, 2013, 2015, and 2017. The red bars correspond to public colleges, so the average among all public colleges, while the black bars represent the averages among all private colleges. And so along the y-axis here, we have values in, these are thousands of dollars. So for instance, in 2011, among public colleges, the average annual cost for a room and board was $4,820, while the average for private colleges was $5,410. So let's see if we can model this data and maybe make some predictions of what would happen, for instance, say in 2019. So I'm going to turn to my calculator, and here I have three lists. In the first one I have years, but now notice I put 1, 3, 5, and 7. So these correspond to the years after a baseline. So the baseline that I'm using is 2010. So this is 1 year after. This is 3 years, 5 years, and 7 years. So that's how I'm getting these values of 1, 3, 5, and 7. In list 2, I have the values. Those are the averages for the public colleges. And in list 3, I have the averages for the private colleges. So let's look at first at a scatter plot, and it should look very similar to the bar graph that we're seeing here. So I want to turn on my stat plot, and the first plot is on with L1 and L2. These are my x values and my y values. I'm also going to turn on stat plot 2. So I'm on. I want to make that a scatter plot, and I'm going to use the values in L1, but this time for my y list I want to make sure I select L3, and then I can go to zoom. Clear. Just hit enter here, zoom. So I have both of these values. The higher numbers are for the private colleges, the lower numbers are for the public colleges. So next I'm going to see if I can find a model, a function that will model each of these. Let's start with the public colleges. And I'm going to say, both of these, there might be a slight curve with both of them, so it makes me think that maybe an exponential model would be good. But I'm actually going to do a linear model for the public colleges and then an exponential model for the private colleges. So let's go to our stat options. Under calculations, I'm going to scroll down to the linear regression. That's option 4. And my x values are in list 1, and my y values are in list 2. So that's a comma separated list. Your calculator may give you prompts, and that's fine. And so the model that I'm going to use for the public colleges is 956x plus 3,176. So now let's look at the private colleges. So I'm going to go back to my stat menu under calculations, and this time I'm going to look for the exponential regression, and here that is. Again, I want to tell the calculator where my values are. The x values are in list 1, and remember that my y values are now in list 3. And now I have an exponential model. It's 4,360 times 1.1499 blah 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 raised to an x. I'm going to do some rounding here, and let's see. One second, I'm going to check and make sure I have the data entered correctly. Go to my stat menu and look at my list, and I have 5410, 5840, 9000, and 11890. Oh, I see. All right, now that's fine. So back to my stat calculations and exponential regression. And again, list 1, list 3. So I'm going to copy down that the values here are, let's see, where can I do this? A is 4360, and I'm going to keep no decimals there, and for the B is 1.15, and this is for a function in the form y equals a times b to the x. So really I'm using y equals 4,360 times 1.15 to the x. Alright, now here is my linear model, 956x plus. There's another version of the exponential model here with using base e, which is an option, and this is, I wouldn't get this from the calculator though, so I'm actually going to use the result that we got from the calculator. This came out of the textbook, this was just given, but I'm going to use the value here. So again, these will tell us the averages X years after 2010. So the first thing that we're going to do is to use our linear model to predict room and board at the end of 2015 school year. And we'll do this for public colleges. So I'm using my linear model. So in 2015, I want to evaluate the function at 5. So I'll go back to my home screen, and I'm taking 956 times 5, and then adding 3,176. And that turns out to be 7,956. The actual value was 7,500. Let's do the same. Let's evaluate for 2015 using the result from our calculator, this exponential model. Let's find the public college's estimate for room and board. So I'll evaluate this function at 5. So I'll call this, say that y equals 4,360 times 1.15 to the 5th power. So 1.15 to the 5th power times 4,360, and that equals $8,769.52. So slightly lower than the observed value of 9,000. And we could do the same thing to make a prediction for what would happen in 2019. So which of these was better for 2015? So to say which was better, I would look at how far off they are. The observed value was 9,000, so if I take 9,000 and subtract 8,769.52, this was off by $230.48. For my linear model, I had 7,956 minus the actual observed value of 7,500. That was off by $456. So the better model in the year 2015 was the exponential model for private colleges. And I actually feel like we might have gotten a better result if we'd used an exponential model for the public colleges as well. All right, so if we wanted to make a prediction for 2019, that would be 9 years after 2010. So I could evaluate f of x at 10. So in other words, I would take f of 10. And so 956 times 10, and then add 3,176. So the prediction there is that in 2019, the average room and board for public colleges would be 12,736. And if I use my exponential model for the private colleges, I would take y equals 4,360 times 1.15 to the 10th power. So 1.15 to the 10th power times 4,360. And that comes out to be 17,638 and some change. So if this is true, there would be a big change, a big jump between 2017 and 2019. So remember, when you're using an exponential model, we have growth that steadily that increases quickly. So you should see big jumps from year to year. All right, so there is another example of how we can use these models. If you want to play around with it, one thing that you could do is go back and find the an exponential model for the public colleges and see if it does a better job of making a prediction for 2015. So if it reduces the error. I'll be back with one more example in the next video.